condition and we can finish our meeting this morning strong. Okay, how about the people at the back? Are you class doing right there? Okay, that's good to hear everything is well. Can you please come forward here? No? Can you please come forward here for us to have a uniformity? And please pick up some pieces of paper under your chairs and arrange your chairs properly, okay? We don't tolerate any uncleanness here in our classroom, okay? Okay, thank you so much. But before anything else, let's have our prayer first. Please, Ariel Gonzalez, lead us in prayer. Okay, may I request everyone to please all stand up and let's have our prayer. In the name of the Father, the Son, and the Holy Spirit. Amen. Okay, thank you so much everyone. You may now all please be seated. And for your attendance class, I have here a sheet of the paper. All you have to do is to have your names written in here and have it signed, okay? To those students who will be able to have their names written and have their names signed here, will be automatically marked as absent during my class. Are we clear? Okay, very good. We are clear with our attendance, okay? And before we dive into another discussion or another lesson this morning, I have here a set of classroom rules that we have to follow, okay? For us to have a better interaction and a peaceful class during my time, okay? So when I say you listen, listen has a definition, okay? So, listen stands for lower your voice, increase your attention, search your goal, ease your mind, engage in class, and last but never the least, never leave your notes blank, okay? Are we clear with our classroom rules? Okay, very good. We are clear with our classroom rules. And with that, allow me to ask you a question, everyone. Okay, have you ever wondered how our phones receive calls and messages even without wire and not connected at the something? Now, have you ever wondered when you text your crush? Now, when you receive phones and messages to your crushes, have you ever wondered how is that possible? Okay, how about when you're using the television and you wanted to switch to your favorite noontime show? Let's say, for example, it's Showtime or MMK. You use the remote control and you switch it to your favorite channel. Have you ever wondered how is that possible? Okay, or how about the very thing that is happening inside of a microwave when you use or heat your food? Have you ever wondered how is that possible? Anyone from the group? Yes, Baya, you are raising your hand. In the context of microwave. Okay, that is an interesting answer. Thank you for that, Baya. So according to her, now it has something to do with the electricity. Of course, when you're using the microwave, you have to plug in first in order to use the microwave. Okay, but later, as we dig deeper with our discussion, we will find out now what is the reason behind all of that. Okay, and so as a sort of review, last time we talked about how electricity is related to magnetism. Am I correct? Okay, very good. So as a sort of review, what is electricity again? Okay, Delinia, you are raising your hand. Okay, very good. Thank you, Delinia. So electricity is a phenomenon associated to stationary or moving electric charges. How about this area from this group? How about magnetism? Yes, Barbon. Okay, thank you, Barbon. Very good. So magnetism is a phenomenon associated to magnetism itself, and it arises from the electric charges. Very good. It seems like you guys did listen very well to our discussion last meeting. Okay, but before we move on to a different lesson, let's play a short game first, okay? For you class to somehow lubricate your bones, okay? Alright, so are you all familiar with what I have here? This is a mystery box. Are you all familiar with this one? Okay, everyone is familiar with a mystery box. That is very nice, okay? So, general instruction is the mystery box will be passed around the class, and the eye of the teacher will play a music or song. The moment the song stops, the students holding the box will have to pick an item inside and try to guess what is the item or object is referring to, just based on your own understanding line. Okay, are we clear with the instruction? Okay, very good. So without further ado, let's now begin. Okay. The box. Okay, let's see what we got. Show me in the class. Okay, you got what is it? What do you think it is? Okay, very good. It is a sunglasses. What do you think sunglasses are used for? Okay, very good. To protect us from the blinding lights of the very sun. And what do you think that harmful sun is producing. Very good. UV radiation or UV light. Okay, thank you everyone. So with that, what can you observe based on the items or objects inside the mystery box? What do you think they all have in common? Anyone? Yes, Nabanwa, you are raising your hand. Very good. They are invisible, right? They cannot be seen with our naked eye. No? And how about this area? Very good. Kapistisan. No? They all exhibit wave-like property, just like an electromagnetic wave. Okay, very good, everyone. So with that, allow me to present to you our lesson objective this morning. Everyone, please read what is our objective this morning. Okay, so identify the different forms of electromagnetic waves in terms of their frequencies, wavelengths, and energy. Value the importance of electromagnetic waves in our daily life. Okay, thank you so much everyone. So in this morning, we will going to talk about or discuss about another topic which is the electromagnetic wave. Okay, so we are going to talk about or dwell about electromagnetic wave. Okay, but before that, let's have a group activity first, okay? So that you can uphold your critical thinking skills and collaboration skills. So at the same time, this will be the group 1 and this will be the group 2, okay? Group 1 will be doing invisible light test and group 2 will be doing a radio wave blocking test. Okay? So choose a leader, a secretary, and a reporter to report your work. Alright? Remember, you only have 5 minutes to finish this. So finish or not finish, you have to pace and present your work. Okay? So you may now start the moment I hand it to you or you receive the envelope. Okay? But before that, what are again the things to remember when doing a group activity? Yes, Luminay, very good. Work silently. Yes, very good. Now participate or cooperate. Okay, you may now begin the moment you receive the envelope. Group 1 and group 2. Okay? Okay, time is up. Finish or not finish, please face your work here in front. Group 1 and group 2. Okay, so be ready to present your work. Okay, so for group 1, okay, give me a minute to face all of this, no? For group 1, please here with group 1. So later, as we dig deeper in our discussion, we will check the work of everyone, okay? But before that, let me paste your work first, okay? Let's see if you, class, has the correct answers later as we dig deeper with our discussion, okay? Okay, thank you group 1 and group 2. Okay, when you hear the word electromagnetic waves, what does come into your mind? Anyone from the group? Yes, Escalian, you are raising your hand. Okay, okay, thank you for that interesting answer, Escalian. According to her, when she thinks about electromagnetic waves, it makes her think about microwave again. Okay, and why is that so, Escalian? Okay, so according to her, it has something to do with the electricity. Of course, obviously, when you wanted to use a microwave, you have to plug in first into a electricity, right? Before you can use it. So, with that, now it has something to do with the electricity itself. Okay, thank you for that interesting answer, Mrs. Canadian. Okay, but what is really electromagnetic wave? Okay? Alright, so electromagnetic waves are one of the many ways that energy travels through space. So the heat from a burning fire, naglungag ka, the very heat there, and even the sunlight na nagluwas ka, are forms of electromagnetic radiations. Also, the X-rays that are used by your doctors to examine your broken bones, broken fractures, broken heart, are all forms of electromagnetic radiation. And as well as the very thing that is happening inside forms of electromagnetic radiation. Okay, but what is really electromagnetic radiation? Okay? All the forms, they might quite seem different from one another. They are related and that they all exhibit wave-like properties. Okay, but what is really electromagnetic radiation, everyone? Okay, we'll find out. So everyone please read what is electromagnetic radiation. Okay. Everyone please read what is electromagnetic radiation. Okay, so electromagnetic radiation or electromagnetic wave is a self-sustaining energy with electric and magnetic field components, and it's commonly referred to as like EM, EMR, or electromagnetic waves. The waves propagate through a vacuum at the speed of light. Okay, you stop there. Thank you, everyone. So basically, electromagnetic radiation or electromagnetic waves are just energy that travels in waves. Okay, and it has two major components, which is the electric and the magnetic field components. If there is no electric or magnetic field component, or there is one absent there, then that will not make electromagnetic radiation. It must be the two that is present, okay? Alright. And electromagnetic radiation is commonly referred to as light, EM or electromagnetic, or EMR or electromagnetic radiation, or electromagnetic waves. So you choose where you are comfortable to the names mentioned here, which you are comfortable to use, since they are all the same, alright? Okay, so you choose either light, EM, EMR, or electromagnetic waves. Now the waves propagate through a vacuum. Now through a vacuum, this means that the electromagnetic waves, they do not require any medium like other waves, like the transverse waves. The transverse waves class is when you tie a rope into a tree and you oscillate or make it up and down motion. That is an example of transverse wave, which is they require a medium. But that is another topic to discuss. Let's focus on electromagnetic radiation, alright? Do not require any medium, meaning they can travel anywhere, any space, and through a vacuum. Alright? Okay. And they travel at the speed of light, which is the fastest possible speed here in the universe. Can you all still remember the constant speed of light? Anyone? Yes, very good. Now 3 times 10 raised to the power of 8 meters per second, which is the constant speed of light. Which is 3 times 10 raised to the power of 8 meters per second, or 300 million meters per second. This is the constant speed of light, which is the speed all the EM waves travel to the fastest possible speed here in the entire universe. Okay? And the oscillations of electric and magnetic field components are perpendicular to each other and to the direction of the wave which is moving. Meaning, the oscillations of electric and magnetic field class will always be perpendicular, meaning it will always be 90 degrees angle from each other. Because the position of the oscillations of electric and magnetic field class, they are like a cross. They are overlapping. I mean intersecting rather. So this is something like this, intersecting. So let's say in the vertical area is where the electric or the magnetic field oscillation, and also in the vertical area. It's either electric or magnetic field. But let's say, for example, the upper portion is the electric field, and the horizontal area is the magnetic field. And this is where the direction of the wave which is moving. So it would look like this, like an L. Meaning, if this is where the electric field components, it will be always perpendicular, facing the right angle of 90 degree angle. This is where the magnetic field, just like an L. Okay, always perpendicular. Alright. And the waves are characterized according to their wavelengths, frequencies, and energies. Okay. If we have electron and proton as the tiny particle present inside of an atom, how about the tiny particle present in the light? What do you call that? Anyone? Yes! The Stura. Yes, very good. Photons. So photons, or small packets gravity just like any normal matter. This is because the speed of all the EM waves is the constant speed of light, which is the fastest possible speed here in our universe. Okay, and even though they travel at the same speed, which is the speed of light, they do so at different levels of frequencies, wavelengths, and photon energies. Alright? Okay, so I have here the EM spectrum, or the electromagnetic spectrum. Now, the EM spectrum class encompasses, or is the entire range of the electromagnetic waves. So in order of increasing frequencies to decreasing wavelengths. So as you notice, as you go from your right to left, as the wavelengths get shorter, the frequencies gets higher. This is because the frequency and wavelength, or wave size, they have this thing called inverse relationship. Okay? So the frequency and the wave size, or the wavelength, they have an inverse relationship. What is an inverse relationship, sir? Okay, so inverse relationship class, as the other goes up, the other one must goes down. Must goes down automatically. So let's say, for example, as the frequency gets higher, it will automatically, the wavelength gets higher, or vice versa. As the wavelength gets higher, the frequency gets smaller. This is because they have an inverse relationship. Okay? Now, the EM spectrum class, or the electromagnetic spectrum, encompasses all forms or all types of electromagnetic radiation. So, from the highest frequency to the lowest frequency, to the shortest wavelength, to the decreasing wavelength, and to the highest energy, and to even the lowest energy. Okay, so based on the illustration, can you tell what is the correct order of the EM spectrum? You start right here, class. Okay? We have radio wave, we have microwave, we have infrared, we have visible light, we have ultraviolet, we have X-rays, we have gamma rays. Okay, now for you to easily remember the correct order, or the correct format of the EM spectrum class, I want you to always remember this mnemonics, okay? Which is rabbits mates in very unusual, expensive gardens. Okay, so let's read it all together for you to easily remember the correct format or order of the EM spectrum. Okay, read it with me. Ready, set. Rabbits mates in very unusual, expensive gardens. Okay, so R stands for the radio wave, M stands for microwave, I stands for the infrared, V stands for the visible light, U stands for the ultraviolet, X stands for the X-ray, and G stands for the gamma rays. Alright, so again, for you to easily remember the correct order or format of the EM spectrum, I want you to remember this mnemonics, because this will help you to remember this correctly, okay? Okay, very good. Alright, now, so there are actually 7 types or 7 forms of electromagnetic radiation or electromagnetic wave. Let's start from the first one, which is the radio wave. Okay, everyone, please read what is radio wave. Okay. Radio wave have the longest wavelength in the EM spectrum. They are used to transmit sound and picture information over long distances and have a very wide range of wavelengths. Okay, thank you everyone. So radio wave have the longest wavelength in the EM spectrum, and we can clearly see that it is prominent because as you see right here, it almost covers the entire range of the EM spectrum, right? So thus, making the radio wave have the longest wavelength. And these longer wavelengths of radio wave bands are even divided into smaller regions called wave bands. That is why, as you notice in our radio station or in the context of radio, it is almost impossible to maximize or to run out of station because the wavelengths of radio wave are even divided into smaller regions called wave bands. Okay, so but Again, what are the local radio stations that you are familiar from? Okay? Yes, Gaya. Yes, MOR. MOR or 101.9 FM, right? Okay. How about here in our locality, in San Carlos City? We have, very good, we have Brigada News FM. So, as you notice, there is an FM into their every names, into their every names of their radio station, right? Okay, that is because that FM actually stands for frequency modulation. Okay, what is frequency modulation, sir? Okay, so frequency modulation helps the radio station to transmit and receive messages from other sender. Now that is why frequency modulation. And as you notice, that there is this number in their names, right? In the radio station names, such as the MOR or 101.9 FM. That number is actually stands for their frequency in the radio wave. Okay, that is why that it is almost impossible to run out of radio station because radio wave has the longest wavelength in the EM spectrum and it is even divided into smaller regions called wavebands. Okay? Alright, and since we're talking about radio wave, let's check the work of group 1, okay? If they got the correct answer. So, I mean rather, group 2. I stand corrected. No, group 2. Since they did a radio wave blocking test. So, what did you observe when you wrapped the phone in aluminum foil and calling it? So, they answered it didn't receive any calls and messages. Okay, this is because radio wave travel in a line of sight. Since all of the EM waves travel in a line of sight, meaning they are susceptible to interference or disturbances, especially that is why as you notice during any catastrophic events or calamities during typhoon, it seems like radio waves nowhere to be found, right? You have to find a better position or a better signal to receive or to send messages because radio waves are susceptible to disturbances or interference. That is why you don't receive any calls or messages when you wrap the phone by aluminum foil. Okay, so this one is correct. And the number 2, what these experiments tell us about how radio waves travel through different materials. Radio waves cannot pass through certain materials like aluminum foil. Again, that is because radio wave is susceptible to disturbances or interferences. Okay? And the last question, what might happen if all radio waves were blocked? How will it affect communication and technology? So there will be no cell phone signals, making communication and technology uses. Of course, obviously, there is no, if we block all their radio signals, it would be difficult, no? It would be life-changing, especially in a life or death situation. Because during an emergency, how are we going to call an ambulance if all the radio wave signals are blocked, right? So it would be hard. Okay, this one is correct. So group 2, with that you'll be receiving 20 points from me. Okay, so 20 points. Okay, with that, let's give group 2 a Okay Na To clap by Mami Grace Felix. Okay, are you all familiar how to do a Okay Na To clap by Mami Grace Felix? Okay, Dile. So this is how you do a Mami Grace Okay Na To clap. Okay, so 1, 2, 3, 1, 2, 3. Okay na to. Okay, everyone. Ready after me. Ready, set? 1, 2, 3, 1, 2, 3. Okay na to. Oh, see, very good group 2. Okay, so let's move on to the second type of electromagnetic waves. We have microwave. Okay, so we have microwave. Okay. Dilinya, please read what is microwave. Okay, Dilinya, please read. So, microwave are the highest frequency electromagnetic waves that can be produced by current in microscopic circuit and devices. Okay, you stop there. Thank you, Dilinya. So, microwave have the highest frequency electromagnetic waves that can be produced by the human or man-made. The man-made microwave are the highest frequency. This is the only limit that man-made can produce. No high frequency in a microscopic circuit devices. Alright? And the microwave can be found here, right here. It has a frequency that ranges to 10 to 9 to 10 to 12. Now, do not be confused class because the frequency here, the exponents here in the frequencies are actually in the form of scientific notation. And the wavelength is also in scientific notation, but they are in meters. Now, let's have a short review to what is scientific notation, okay? So scientific notation actually helps you to write huge numbers, particularly with zeros, not to write it in shortcut. Now, basically, bypassing writing these huge numbers, especially with those numbers, huge numbers with zeros. So let's take, for example, this 10 to 9. Okay, so in scientific notation. In scientific notation, 10 to 9, okay. Now, so 10 to 9. 10 to 9. But the frequencies and wavelengths are in 10 forms class. So this is not how you formally write it. Meaning, we had to add 9 zeros to 1. Okay, but this is how you formally write it. 1 times 10 raised to the power of 9. Okay. Now, in the class that if the exponent is positive, meaning we add zeros to our right, and it is in greater number. And if the exponent is in negative form, we add zeros to our left, meaning that is in decimal form and that number is lower. Okay? So we have 1 times 10 raised to the power of 9, meaning we add 9 zeros to the number 1 to our right. Okay? We add 9 zeros. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Meaning, this one is now 1 billion hertz since it is in frequency. Okay. Now let's try the negative exponents. So let's say for example this one is in negative 4. No, negative 9. So meaning this is in decimal point, and we add zeros to our left side. Okay? Meaning 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 0.0000001 hertz. Okay, that's scientific notation class. Alright? Microwave have smaller wavelengths but has higher frequency and energy. Now, microwaves class have higher frequency and it actually corresponds to their shorter wavelengths. Thus, the name microwaves. Alright? Now, they are used in satellite communications, radar, television transmission, and my favorite part, which is cooking. Okay? And now, let's move on to the third type of electromagnetic wave. We have the third one, which is the infrared radiation. Okay? All of this read what is infrared radiation. Make it loud so that everyone can read it clearly. Okay, infrared radiation. All of this read. So, infrared radiation lies beyond the red end of the visible light. The amount and wavelength of radiation depend on the temperature. Okay, you stop there. Thank you, Clara. So, we can see here, or we can locate infrared radiation at the very reddish area, or the red end of the visible spectrum here. Okay? And the amount and wavelength of radiation largely depends on its temperature. Okay, let's take this as an example, guys. Let's say, for example, this dog goes to a room temperature above 500 degrees Celsius. Meaning, the dog will start to emit infrared radiation. And if the dog goes to a temperature below 500 degrees Celsius, the dog will start to emit some infrared radiation, but at the same time, it will glow some visible light. This is because infrared radiation just lies beyond the visible light. Now that is why it also emits or glow visible light, as you can see here in the picture. Okay? Alright. Now, longer wavelength infrared wave produce heat that include the radiation emitted by fire, the sun, and other heat-producing objects, including your freshly secreted urine. As you notice, our urine, our freshly secreted urine, is hot, right? That is because producing heat-producing object. Now, when projected to infrared radiation, it will emit infrared radiation or infrared light. Okay, now shorter wavelengths infrared rays do not produce much heat and are used in remote controls and imaging technologies. And according to my research, research, they are using remote control because they are much more cost effective compared using other Bluetooth devices. Now, the only downside is that they require a line of sight to function. That is why, as you notice, when you want to switch to a different channel and someone is blocking your line of sight, you have to move the other way around, or you have to find a better position so that you can switch the television using a remote control. And where do we find commonly places that are using infrared radiation in the context of transportation? We have, and what? Yes, very good. We have airport. Okay, in the airport. So if you're planning to go to a different country or go abroad, and you are in the transportation of airplane, before you can go to that specific country, you have to undergo the infrared scanner. This is because now using the infrared scanner, it detects the abnormal heat since we are producing heat, right? Our body produces heat. Am I correct? Okay, yes. And that is where they can detect if you have this abnormal temperature, then there must be underlying issues right there. It must be you have fever or you acquired some certain viruses, right? In the context of medicine or health, they are using infrared radiation. Alright? And let's move on to the fourth type, which is the visible light. We have visible light or the rainbows, which composed primarily by the RGB, or the red, orange, yellow, green, and blue, and violet. Okay? Which red has the shortest wavelength, meaning it has the shortest frequency among all of the colors, because again, there is an inverse relationship of frequency and wave size or wavelength, right? Okay, that ranges between 622 to 700. Orange ranges between 597 to 622 nano. This is in nanometers. Yellow ranges between 577 to 597. Green ranges from 492 to 577 nanometers. Blue ranges from 455 to 492 nanometers. Violet, indigo, which is has the shortest wavelength. Thus, it has higher frequency because again, the frequency and wavelength has this inverse relationship. As the other goes up, the other must goes down. But it is not higher than ultraviolet. Okay? It is not higher than ultraviolet. Now, the visible spectrum, also known as white light. Okay, you did this experiment a while ago, right? You did this experiment a while ago using a visible light and a prism. So, white light is the tiny portion of spectrum perceived by the human eyes. This is because, class, our eyes, or the human eyes, is sensitive to this range, which is 4 times 10 raised to negative 7 to 7 times 10 raised to 7 meters. And this is the range of white light. Higher or lower than that, we have to use or need the help of other objects such as lenses and specified mirrors to see beyond or lower from this range, because this is our human eyes are sensitive to are in limitation. So this is where we can only see, this is the only limit our eyes are sensitive to and we can perceive, which is the white light. So you did this experiment a while ago, right? Particularly in group 1. So let's check the work of group 1. Okay. So group 1, what did you observe when you let light passes through the prism? So we observed that the light separated into its constituent colors. Right? So with the help of the prism, not just like this one, using a prism, the white light, when passes through the prism, now it separates to their constituent colors. Okay, that's one shot for group 1. Alright? So what would happen if our eyes could see other electromagnetic waves like ultraviolet? How would it affect our daily life? So they answered, we might see harmful rays. It may be helpful in some situations, but it is also also overwhelming. Okay, so now though you seeing ultraviolet, now let's say for example, they are seeing ultraviolet, we have the ability to see ultraviolet. Though it might be helpful in some situations, but in the worst case scenario, it might also be overwhelming. Because imagine, ultraviolet is violet, right? You see everything as violet. So it might be overwhelming for us. Okay, so the group 1 was check for this one. Okay, and if light waves can be bent or reflected, how do you think this principle is used in eyeglasses, cameras, or microscopes? The answer, they all uses lenses to bend light, helping clearly or zoom objects. Okay, so this analogy can be compared to how rainbows are formed. Okay, because how do rainbows forms again? Now, rainbows are formed after rain, after the rain. This is because the water molecules or the tiny water molecules after the rain reflects or refract, actually bends the light for us to see the colors. Now, the RGB in particular, they allow the white light to separate from its constituent colors, which is the RGB. Okay, so this can be compared to the use of eyeglasses, cameras, or microscopes. So with the use of the lenses and types of mirrors, now it can actually help us to see clearly or zoom in any object, which our eyes cannot, because our eyes is only sensitive to this one, to this range, which is the white light. So higher or lower than that, we need to use other objects, or we need to use the help of other specified mirrors and lenses. Okay, this one is correct. So group 3 will also receive 20 out of 20 from here. Okay, so for group 1, let's give them a sobrang Latina clap. Are you all familiar to how to do a sobrang Latina clap? Okay, not. So this is how you do a sobrang Latina clap. Okay, 1, 2, 3, 1, 2, 3, sobrang Latina. Okay, pointing out to the group 1. Okay, ready, set? Okay, 1, 2, 3, 1, 2, 3, sobrang Latina. Okay, congratulations everyone for a job well done and for completing your work. Okay, very good. So let's move on to the fourth, which is the ultraviolet rays. Okay, so ultraviolet rays. Everyone please read what is ultraviolet rays or ultraviolet radiation. Okay. Ultraviolet or UV light is an EM radiation with a wavelength shorter than that of visible light, but longer than X-rays in the range of 10 nanometers to 400 nanometers. Okay, so even though ultraviolet light is invisible to our eyes or to the naked eye, there are some insects, now particularly bumblebees in particular, can actually perceive and see ultraviolet rays. This is their perspective. So this is the perspective of the bumblebees. They see almost everything as color violet. And this is our POV or the human, which we see colors properly, right? This is because bumblebees has this thing called photoreceptors. They have this thing called photoreceptors, which actually helps them to see colors, patterns, and UV light, which as humans cannot, because we lack these photoreceptors. Alright? Now, ultraviolet radiation lies beyond the violet end of the visible spectrum. So, to look at ultraviolet, it lies beyond the very end of the visible light. This one. So, meaning it lies at the very end, meaning it has the shortest wavelength. Thus, it has the shortest wavelength. It has more frequency because again, there is an inverse relationship between frequency and wavelength. And always remember guys, the higher the frequency, the more energy the wave carries. Meaning, it is much more dangerous. Okay? That is why too much exposure to UV light or UV rays, which causes us humans what? It causes us, yes, very good, it causes us sunburn. So UV waves causes us sunburns, and in most case scenarios, too much exposure now can cause cancer in living organisms or skin cancer as as carcinoma and melanoma. But that is another topic to discuss. So meaning UV waves are dangerous. So too much exposure to UV waves can cause us sunburns and mostly scenarios, skin cancer. Alright, now let's move on to the sixth type of EM wave. We have the X-rays. Okay, we have X-rays. Now, what is X-ray? X-ray, please read everyone what is X-ray. Now, X-rays. They are of shorter wavelength but carries higher energy than UV, produced using an X-ray tube. Alright, X-rays has higher frequency than UV light, meaning it is much more dangerous than UV light, and they are produced using an X-ray tube. What is an X-ray tube, sir? X-ray tube class, this is when accelerating an electron and eventually causing them to decelerate when they are struck or targeted to a metal or a certain material using an X-ray tube. So this is a man-made X-ray. So this is what an X-ray looks like when you go to a doctor. Now, particularly in radiologists, since they are professionals for using X-rays. Alright? So X-rays are extremely high energy waves with wavelengths between 0.003 and 3 nanometer, not longer than an atom. They are emitted by sources producing very high temperatures, such as the sun's corona. So the sun's corona are X-ray producing. The sun's corona can only be observed during a solar eclipse, right? Particularly annular solar eclipse. That ring structure look like, that is the sun's corona, which is the outermost layer of the sun's atmosphere, meaning they are X-ray producing. Alright? Now, commonly used in imaging technology to view bone structures within the body. So X-rays was discovered by Wilhelm Conrad Röntgen way back in 1895. So thank you so much, Wilhelm Conrad Röntgen, because of his discovery, it revolutionized the context of medicine in our world, right? Because of the X-rays, it helps us to locate what is wrong with our fracture, right? And to give appropriate medications or treatment with the use of X-rays. Okay. And now let's move on to the last type of electromagnetic radiation or electromagnetic wave. We have the gamma rays. The gamma rays, everyone please read what is gamma rays. Gamma rays lies at the other end of the electromagnetic spectrum, meaning it lies at the other end, meaning class, it has the shortest wavelength, thus it has the highest frequency. Since it has the highest frequency, meaning it is the most dangerous type of EM wave, since they carry much more energy, dangerous than ultraviolet, dangerous than X-rays, since gamma rays are the most dangerous form of electromagnetic spectrum. They are shortest in wavelength and highest in frequency. Gamma rays are emitted by stars in some radioactive substances, can only be blocked with lead and zinc concrete, and they are very strong. Yes, gamma rays are very strong since they lie at the very end of the spectrum. And when they are projected to humans, now it can actually kill good cells. Now, but in the context of medicine, scientists amplify the gamma rays, which through the process called radiotherapy. What is radiotherapy? So radiotherapy, they amplify the gamma rays to target the good cells. Rather to target the bad cells. So meaning, through the process of radiotherapy, they have to treat cancer patients. Meaning they are targeting the bad cells or the cancer cells, which eventually shrinks your tumor and leaves the pain of the patient and make it bearable. The cancer make it bearable for them, since there is still an unknown cure for cancers, right? Okay, this is one of their therapy to at least somehow ease the pain of the cancer patient through the process of radiotherapy. Okay, and now always EM spectrum is that they do not require any medium. No, they do not require any medium to travel. They travel to space and through a vacuum. And the inverse relationship between frequency and wave size. So as the other goes up, the other must go down. And as the higher the frequency, the more energy it carries, making it much more dangerous. Okay? Alright, now I have here a situation class for you to ponder and at the same time for you to answer. Okay. Everyone, please read our situation. Okay, so imagine you and your friends are spending a fun day at the beach. The sun is shining, people are capturing precious moments using their cameras. A lifeguard is using a walkie-talkie to keep everyone safe, and a nearby hospital is using x-rays to help injured tourists. Now the question is, so how do EM waves improve our lives? Imagine a world without them. No sunlight, no phones, no internet, no medical imaging. How would life be different? Yes! Yes, Victoria, you are raising your hand. Okay, very good. It would be life-changing and it would be hard because in the context of medicine, we are using x-rays, right? To help cure the patients just by scanning their broken fractures, broken bones, to seek or to advise appropriate medications depending on the level of their injury. So it would be totally hard if there would be no EM wave here in our body, right? It would be totally different. Life would be totally different. Okay? While EM waves brings many benefits, some can be harmful, like UV rays, so too much exposure to UV rays. How can we use them wisely to protect ourselves? Anyone? Yes, Manina, I know you have some ideas. Okay, very good. So, now, if you are a radiologist and you are using x-ray, so you must follow the safety protocols in your office or in your work area or work etiquette. So wear PPE, personal protective equipment, and follow the safety protocols to avoid too much exposure to x-rays or to worst-case scenario that would deteriorate your health. And if you are out of the shade of the sun, you wanted to go out, now wear sunscreens or sunblocks to protect from the harmful UV rays. Like a very good thing. And we have the last one. How can understanding them help you appreciate modern technology and nature? Yes, the niya. Okay, very good. So it highlights or talks about nature is power, right? Because the EM wave or the EM spectrum are all naturally occurring. Meaning it highlights that nature is power and nature will conquer us all. Okay? Alright. Now, is there any questions or clarifications you wanted to ask? You may now ask now. None? Okay, well then, I will be the one to question you then. Okay, what is again electromagnetic waves? Yes? Escaligan? Okay, very good. So electromagnetic waves are basically waves that travels in space or through a vacuum. Energy that travels in space or a vacuum. We have two main components. We have the electric field and magnetic field components. They do not require any medium. They travel through space at the constant speed of light. So there are 7 forms of electromagnetic wave. Give one. Yes. Ribbon. Very good. Radio wave. We have radio wave. Radio wave have the longest wavelengths in the EM spectrum. More. Yes. That's decent. Okay, very good. We have microwaves. Microwave is the highest frequency us human can produce. Okay, and some more. Yes, auto. We have infrared. Infrared, which lies beyond the reddish end or the red end of the visible light. And we have the visible light. Okay, very good. Auto. We have visible light, which is the raging wave. Now the red, orange, yellow, green, blue, and violet or indigo. We have more. We have ultraviolet. Okay, very good. We have ultraviolet, which is the very energy that suns produce, and that causes us sunburns and skin cancers if too much exposure. Okay, some more. We have very good. X-rays. X-rays is the now in the context of medicine, it helps us to see through our bones. Okay. And we have the last one. Anyone? Yes. Buloy. Gamma rays. Okay, very good. What is gamma rays? Okay, the highest frequency among all of them, making it much more dangerous, no? Lies beyond that other end of the EM spectrum, making it much more dangerous than else. Since it has the shortest wavelength, meaning it has the highest frequency. Thus, it has the highest frequency, it carries more energy compared to all. Alright, well then, if there is no answers, if there is no questions or clarifications, we'll be having a test, okay? Okay, well then please get 1/2 crosswise, we'll have a test, okay? Now, direction is compare column A to column B and choose or identify the correct answer in column B. So use the table 1 as your reference, since the table 1 has all the information you need from the frequencies, wavelengths, and photon energies of all the EM spectrum, okay? Alright, we will now begin, and for your assignment, you're gonna be doing a EM wave hunt. Okay, so go out in your community, find 5 objects that are EM waves producing or are using EM waves. And take a picture, paste it in your science journal, and have your reflection on that, okay? Are we clear with the instructions? Okay, well then, we have now reached the end of our discussion and have